Very good morning to everyone. Let us discuss about the mechanism and machine theory here in static balancing with elastic system of delta parallel robots. The abstract says this paper presents new design solutions and the corresponding mathematical models for static balancing of delta parallel robot. The static balancing of parallel robot is a more difficult task than the serial robot one because the parallel robots consist of multi-loop spatial kinematic chains. Generally, these robots can be easily statically balanced only approximately. To statically balance the delta robots, two constructive solutions are proposed. The first one is a new constructive solution for full balancing, and the second is a specified full balancing version with an acceptable balancing accuracy. The term full balancing is used here to denote that the masses of all links and springs are taken into account. To obtain the full balance of the delta parallel robot, three elastic systems for each connecting kinematic chains are assembled. It is further noted that in this study, only the balancing by using the zero free length elastic system is considered. The static balancing result, according to the first solution, is very good, but the structure is not simple, using many additional links. The second simplified version uses one single elastic system for each connecting kinematic chain. Finally, a case study is presented in order to evaluate the performance of the simplified proposed version. It was found that the maximum driving moment decreases about 20 times relative to unbalanced version. Let us discuss about the introduction part of the paper, which is proposed two constructive solutions for static balancing of the delta parallel robot. Namely, the first one is new constructive solution for full balancing, and the second one is a simplified full balancing version with an acceptable balancing accuracy. The term full balancing is used here to denote that the masses of all links and springs are taken into account. To obtain full balance of the delta parallel robot, three elastic systems for each connecting kinematic chains are assembled. It is further noted that in this study, only balancing by using the zero free length elastic system is considered. The paper is structured as follows. The section 2 presents the structure of the delta parallel robot, while the third is about the static balancing of rocking element around a horizontal fixed axis. The fourth one states the static balancing of an element which is moving around a fixed point present that the static balancing of a rocking element around a horizontal fixed axis and around a fixed point respectively. In the section 5th, it is shown the first constructive solution while the section 6 shows the second one. Subsequently, in the section 7, the kinematic analysis is formulated, and the section 8 deals with the zero free length elastic system. Finally, the section 9 presents an illustrative example, and the conclusions are present in the section 10. The problem of static balancing came The problem of static balancing came up long time ago as a necessarily to reduce the driving energy consumption to any mechanical system that does not work in horizontal plane. For example, nowadays the static balancing became a usual task for mechanical structures in industrial robots. A spatial parallel robot consists of two platforms, one fixed and the other mobile. In case of non-redundant robots, platforms are linked in parallel by 3 to 6 connecting kinematic chains. The connecting kinematic chains can be planar or spatial, and each one has one or two driving pairs. Sometimes the connecting chain are referred as legs. The static balancing of serial robots was studied in many papers, but static balancing of parallel robots is a relatively new direction of study. One of the researchers that started the studying of static balancing of parallel robot is Professor Clement Gosselin from Laval University in Quebec, Canada. He wrote together with his co-workers many papers about static balancing of parallel robots of different structures with ideal pairs without friction. In one of the paper, the parallel structure is made of planar kinematic chains with 2 degrees of freedom each, resembling the pantograph mechanism for each leg. Two springs are used in order to statically balance the pantograph mechanism. Static balancing of the spatial parallel robots of general shape example, Gulf Stewart platform can be done only partially by using complex elastic system. The other parallel structures are the delta robot with only 3 degree of freedom or of traditional type can be statically balanced much streams. In another paper, the parallel connecting kinematic chain of Penta G mechanism with 5 degree of freedom used like a haptic device are statically balanced by the aid of helical springs. Another author that studied the static balancing of parallel robot is Professor Vigan Ariclian from INSA Rennes, France. In his paper, the new parallel robot called PAMINSA, with a structure composed of connecting kinematic chains of planar pantograph shape, is presented. The static balancing of PAMINSA robot is done by using counterweights. In this paper, the pantograph with 2 degrees of freedom connected between the fixed platform and the mobile platform is used again to statically balance the delta robots. In another paper, the variant with a multi-loop pantograph link is joined between the fixed and mobile platforms. In another Moss Center is presented. The same idea is used in many papers where static balancing of uh, hexapod parallel robot is done using multi-loop pantograph and counterweight. In one of the paper, a design solution which is using multi-loop pantograph statically balanced by normal helical spring is produced.